So we've gone over transformations of quadratics. Okay. The last thing we're going to go over is stretching, compressing, and flipping quadratics. Okay. In the last two videos, we talked about how you must know the original one because we need to have a reference point. Please make sure you know how to do that. If you don't, just watch the other two again. Here's our vertex form once again, something we're new to. And this time, we're going to be taking the A value. Okay? Now, the A value has essentially almost, you could say, three different things it does. The very first one we'll talk about is very simple, and that's if A is a negative term. Okay? So if A equals a negative term, it's going to open downwards, the parabola. And if A is a positive term, which way will it open? Upwards, the opposite. Okay? So what we're going to do for the first one is I'm going to quickly draw the original. We already know the vertex is at 0, 0. We go over 1, up 1. Over 2, up 4. Over 3, up 9. And we do the exact same pattern on the other side because it's symmetrical. All right, we have the original. Now, what I'm going to do is because we know this information, I'm going to draw the original the other way. Now, what that would entail is y is equal to negative x squared. Now, what is my A term here? Negative 1. Technically, there's a 1 there. And in this term here, what's my A term? Technically, there's a 1 there. Okay? So all we've done is flip the sign of it. Negative 1. So, I want you to think of this logically as if we're multiplying. I'm at the vertex. We'll do this one in red. I go over 1. What is 1 squared? Okay? And then what's that number times negative 1? Negative 1. So we go down. Okay? Negative 1 squared is? Times negative 1? Negative 1. Let's do it the other way. We go over 2. 2 squared is? 4 times negative 1. So we go down. 1, 2, 3, 4. Down. Over 2 squared is 4 times 1 times negative 1 is down 4. If we were to go over 3, 3 squared is? Times negative 1? Negative 1. Okay? So that should be the idea to why we go downwards. Because we have a negative value we need to multiply at the end. Okay, very important that if A is any other number other than 1, we need to multiply that term after we've gone through this pattern. Okay, and that's going to help us for our next step here. So I'll just connect the dots from what we had. This is, that should represent, I need to move this book here. Y equals negative x squared. Okay, now there are also two other instances for A. Now, I said it did 3 things. Flipping it was one of the things. We talk about stretches and compressions. Okay? Y equals ax squared. Okay? A being our red term. Now, if A is a term greater than 1, it's going to stretch. And what I mean by that is sometimes they call it getting thinner. Think of it like you have an elastic band and you're pulling it up and down. Okay? And if A is less than 1 but greater than 0, okay? So in other words, we're usually thinking of fractions 1 over something, all right? Not all fractions are less than 1, but we're thinking of fractions that are less than 1 or decimals that are 0 point something. It gets compressed, is the mathematical term, and we could sometimes call it getting wider. Okay? Now let's employ 2 of these tactics here. In the first one, it's wider only 1D?
Yeah.
That's it.
Sure, why would stretch be?
Don't worry, you'll see. Okay. Here we go. So, y is equal to 3x squared. Okay. 3x squared. That means our A value is what? 3. So it's going to be stretched. So let's think about this. This is where you're going to see that what we mean by getting thinner. Our vertex doesn't move, okay? Because our h and k values haven't changed. So the vertex is going to be in the exact same spot. What's going to happen is the shape of the parabola is going to change. So it's a positive 3, so we know we're going to open upwards. I go over 1. What's 1 squared? Times 3. So we go up 1, 2, 3 units. Let's do that the other way. What's negative 1 squared? When we go back 1?
1.
Yeah, negative 1 squared is 1 times 3. 1, 2, 3. Okay. Let's go the other way. Oh, I should have chosen a smaller number. That's okay. We go over 2. What is 2 squared? Times 3. So we go up 12. Let's just estimate. Negative 2 squared. 4 times 3 is 12, right? Identical. So, if you notice, this parabola is thinner than the original one. So when we say it's stretched, what we're saying is think of an elastic band being pulled from top to bottom. If you pull them, it would get stretched, it would get thinner, the elastic band. Okay? Now, I'm going to incorporate a little extra into the last one here to see how intuitive you guys are. Y equals negative, let's say negative 1/2 x squared. Okay, what's my A value? Negative 1/2. Okay, this part's going to be tricky. Let's see if we can do kind of two things at once here. Negative 1/2. Our vertex is going to start where? 0, 0, no change. From there, we're going to normally draw this. We go over 1. What's 1 squared? 1. What is that times negative 1/2? What is 1 times negative 1/2? Negative 1/2. So we don't go up, we go down only half a unit. So we don't go down as far. Same thing with negative 1 on the x value. Negative 1 squared is 1. 1 times negative 1/2 is negative 1/2. Okay, so let's try that again. We go over 2 units. What is 2 squared? 4 times negative 1/2. Negative 2. We go down 2. Okay. 3. This one we're going to be able to get a little more of the graph on. 3 squared is times negative 1/2. 4.5. So down negative 4.5. 4. What's 4 squared? 16. 16 times negative 1/2. Negative 8. So if you notice, this parabola is wider than the other original one. Okay? Oh, that was kind of poorly done. But that one is wider than the original one. So let's go on our graphing program one more time and put in our values. Graph TK. If you guys remember, our values were 3x squared. Okay? If you notice, the red one is thinner than the blue one being our original. We also had negative x squared. Okay? Which is going to be our green one, which is the original shape of the blue, just flipped upside down. And finally, we did add one more to it. It was negative 1/2 x squared. And if you notice, that is wider than our green one. Okay? So, that is how A affects all of these. A flips them, makes them thinner, and makes them wider, depending on what we have.